Hello everyone, welcome back to another video. So in this today's video we will study about capacitance. So first let us know what do you mean by capacitance of a capacitor or capacitance of a conductor. Okay, capacitor of a conductor is defined as it is the ability to store the charges on it. Remember, we are telling on it means it will not store the charges into it. It is stored, the charges are stored on the surface of the capacitor or the surface of the conductor. Okay, there is no any charge inside the conductor. Clearly we are mentioning it as on it. It means charges are distributed on the surface only, and it is given by C is equals to Q by V. Q is nothing but charge, V is potential difference. This can also be written as C is equals to Q into the value of V is, we know that V is equals to 1 by 4 pi epsilon naught Q by R. In the previous chapter we have studied that potential difference 1 divided by 4 pi epsilon naught Q by R. Now this, when you replace in place of V, this will be the reciprocal, that is 4 pi epsilon naught R divided by Q. This Q and Q get cancelled and we will get C is equals to 4 pi epsilon naught R. Next one, the SI unit of this capacitor will be, the SI unit of charge is coulomb and SI unit of potential difference is volt. Therefore C is equals to, or directly we can write it as C inverse of volt, that is SI unit of potential difference, or this is also called as farad denoted by capital F. Okay, once again I will revise it. Capacitance of a conductor, it is defined as it is the ability to store charges on it. This on it is very important. Next, it is given by C is equals to Q by V, that is charge divided by potential difference. Now C is equals to Q into V value is 1 by 4 pi epsilon naught Q by R. When we reciprocal this and write, we will get Q into 4 pi epsilon naught R divided by Q. Here Q and Q get cancelled, left out with only C is equals to 4 pi epsilon naught R. The SI unit of capacitance is farad, that is charge by volt, or potential difference is nothing but charge coulomb divided by volt. Therefore C is equals to C into, okay, therefore SI unit of capacitance is farad. Okay, moving to the next one, we will see the expression for this one. Okay, next we have expression for capacitance of a parallel plate capacitor with dielectric. So first let us see the diagram, that is let us consider two capacitors. One is having charges positive and the other is having negative charge. Okay, and the separation between them be D, that is dielectric T, and electric field is E, and there is surface charge density denoted by sigma, and let this be earthed. Okay, now as I told you, E is electric field, next sigma is surface charge density, next D is dielectric or dielectric medium. Okay, now first of all let us see the equation for electric field. Electric field E is equals to, electric field is given by sigma by epsilon naught, or sigma can be written as Q by A, that is charge by area. When you substitute the sigma value in the previous equation, that is E is equals to Q by A into epsilon naught. Next one, we have potential difference. Potential difference, that is V is equals to, V is given by Q by epsilon naught, or first we will take V is equals to E, into D. We have the value of V, that is Q by A into epsilon naught into D. Therefore V is equals to Q by A epsilon naught into D. We know that C is equals to Q by V, Q as it is, and V value is reciprocal, that is A epsilon naught divided by Q into D. Therefore Q and Q get cancelled. Therefore we clearly get C is equals to A epsilon naught A epsilon naught into D. Now we got this value of C. This is without dielectric. Now when we introduce a dielectric, the electric field will be ER is equals to, or EM we will take EM, electric field of the medium. Electric field of the medium, we can write it as V by D. Yes, V by D. But electric field of the medium will be sigma minus sigma P divided by epsilon naught. Isn't it? Sigma minus sigma P divided by epsilon naught. This sigma minus sigma P will be equal to sigma by epsilon R. Sigma by epsilon R. Now when we replace the values, or when we substitute the values of these things, we will get V is equals to, we already know the formula, V is equals to EM into D. That is potential difference of the medium is equals to electric field of the medium into dielectric, or the separation between them. Therefore EM, that is electric field, is given by sigma minus sigma P divided by epsilon naught into we have D. Okay, now just now I have written the value of sigma minus sigma P, that is sigma minus sigma P is equals to sigma by epsilon naught into D by epsilon naught as it is. Next, this I will just make an adjustment, because you will come to know that is sigma by epsilon naught into D by epsilon R. Correct? Next, sigma by epsilon R, sigma can I replace it by Q by A into epsilon naught into D by epsilon naught. Therefore I purely got the value of potential of the medium, that is Q into D divided by A epsilon naught epsilon R. Okay, next, capacitance of the medium is equals to charge by potential. Therefore Q as it is, reciprocal the value of V, that is A epsilon naught epsilon R divided by Q into D. This Q and this Q get cancelled, left out with the capacitance of the medium A epsilon naught epsilon R divided by D. This is the final expression. Yes, moving to the next expression. Okay, next let us start with capacitors in series and capacitors in parallel. That is series capacitor and parallel capacitors. Okay, first let me draw the diagrams of these two. Series capacitors means okay, okay, and let this be positive, negative charge, positive charge, negative charge. And always remember, whenever we are doing series capacitors, combination of series capacitors, potential will be varying, that is V1, V2, but we will have the same charge will be equally distributed. Therefore, if I consider this as capacitor 1, capacitor 2, and this is the battery, then always remember, this will help you in the upcoming chapter, that is current electricity also, which is varying. The varying constant, the varying value should be taken first, and here the varying value is V1 and V2, but we have charge constant. Charge is same, charge is not changing. We don't have Q1, Q2. Yes, we have V1 and V2. Therefore, V is equals to V1 plus V2. From the formula of capacitors, that is C is equals to Q by V. Okay, I have two capacitors, therefore I write C1 is equals to Q by V1. Why did I take V1? Because here I have V1, V2. Therefore C2 is equals to Q by V2. Therefore when I substitute these values in this equation, that is V, from this calculate V1 is equals to Q by C1 and V2 is equals to Q by C2. Fine. Next, therefore I got the value, that is V value, let me write this V value also. V is equals to, if C is equals to Q by V, then V is equals to Q by C. Therefore when I substitute this, let me take this as equation 1, all these three equations in one, what do I get? Let me just clean this. Yes, that is V value is Q by C is equals to Q by C1 plus Q by C2. Here all Q are same, it will get cancelled, therefore we get 1 by C is equals to 1 by C1 plus 1 by C2. Clear? Next, further, if I take that is effective capacitance as CS, C subscript S, therefore 1 by CS is equals to 1 by C1 plus 1 by C2. Okay, when I take the LCM and write it like this, this will be 1 by CS is equals to C2 plus C1 divided by C1 C2. Therefore CS is equals to reciprocal C1 C2 divided by C2 plus C1. This is the equation for capacitors in series. Similarly, we have capacitors in parallel. Okay, let us first draw the diagram for this one. This is C1, this is C2, and here potential will be constant, but changing is charge. Here I have Q1 and here I have Q2. As I told you, whenever there is a constant value, we don't have to take that. We have to take the changing value, that is variable value. Here variables are Q is equals to Q1 plus Q2. Why? Because we have two different Q1 and Q2, but potential is same, V and V. Therefore, from capacitor's formula, C is equals to, we have Q by V. Therefore, Q is equals to C into V. Similarly, Q1 is equals to, we have C1 into V, and Q2 is equals to C2 into V. When I substitute these values in this equation 1, I get C into V is equals to C1V plus C2V. Clearly V get cancelled. Therefore, left out with C is equals to C1 plus C2. This C, if I consider it as effective capacitance of parallel combination, that is Cp is equals to C1 plus C2. So this is the formula for parallel capacitance. Once I will write all the formulas, that is Cs is equals to C1 C2 divided by C1 plus C2. Okay, and next I have Cm, that is capacitance of the medium, is equals to A epsilon naught epsilon R divided by D. These are the three derivation which we have seen today, and one more very important formula, that is C is equals to Q by V. SI unit of C is, or capacitance is, C or farad. So thank you for watching this video. In the next video, I will discuss about current electricity, and please don't forget to subscribe, comment, like. This supports me, and I feel like making more videos. This motivates me actually. Okay, thank you so much.